Welcome, dear friends. As you settle into the quiet of your evening, allow your mind to drift into the cosmos. This is not just another science lecture, it's a calming exploration where curiosity meets rest. We'll ask questions that may not have easy answers, but in the process, we'll find peace in the wonder itself. So, if you're ready, close your eyes, relax, and let us journey through space and scale together. Have you ever looked up at the night sky and wondered, just how big is it all? The stars, the galaxies, the endless black canvas. It feels infinite. But is our mind even capable of truly grasping the size of the universe? Or do we simply reach a point where numbers lose their meaning? Tonight, we're going to slow down, breathe, and gently unravel this mystery together. When we think about the universe, we often begin with the only frame of reference we truly know, ourselves. The human mind, the human body, the human scale. From the moment we are born, everything we encounter is measured against what we can reach, what we can hold, what we can see with our own eyes. A child stretches out their hands to grasp a toy, and in that instant, their brain is quietly learning scale. A few inches, then a foot. The distance to the table, the span of the room. Our early experiences shape how we perceive size, space, and distance, but they all remain anchored to the human world, the world of meters, feet, houses, and neighborhoods. Even as we grow older, our sense of scale rarely ventures far beyond what we can directly experience. A city may feel large when you drive across it. A mountain may seem vast when you stand at its base. The ocean may feel endless when you gaze across the horizon, the waves stretching into blue distance. And yet, even these impressive scales are still intimately tied to our daily lives. A mountain can be climbed, an ocean can be crossed, a city can be mapped. They are big, but they are not incomprehensible. Our brains evolved for survival in a world of relatively small scales. We learned to judge whether an animal was close enough to be dangerous. We gauged whether a tree was sturdy enough to climb. We calculated the distance to shelter or water. These judgments required an intuitive sense of distance and size, but only within the limits of what was relevant to human life. No one needed to understand the span of a galaxy in order to build a fire or find food. The stars overhead were simply lights in the night sky, beautiful, mysterious, but not something our ancestors were required to measure with precision. It is only in recent centuries that we have begun to stretch our understanding for beyond these immediate scales. When we discovered that the Earth itself is a sphere many thousands of miles across, it was already a challenge to grasp. Sailors circumnavigating the globe brought back proof of its immensity, yet even then, it was a scale we could slowly wrap our minds around. Maps, globes, and travel allowed us to anchor that concept and experience. But once science extended our vision beyond our planet, the challenge of comprehension truly began. Think about the distances we use in daily life. You might say your home is 5 miles from the grocery store. You might commute 20 miles to work. Perhaps you've taken a road trip across the United States, covering a few thousand miles. These numbers make sense because they connect to direct experiences: hours spent driving, landmarks passing by, the changing scenery out the window. But when we move into astronomical terms, when the numbers leap from thousands to billions, our everyday anchors slip away. What does a million really feel like? What about a billion? We can say the words, we can write down the numbers with their long strings of zeros, but the brain resists. We struggle to hold them in our mind. Studies in psychology show that beyond a certain point, humans do not intuitively sense large numbers. They blur together. 1,000, 10,000, 100,000 at some point. It simply becomes a lot. Our minds were not designed to juggle the immensity of cosmic scale, and yet, we try. We invent metaphors, we build models, we create visualizations. We say that if the Earth were the size of a marble, then the Sun would be a large beach ball, some distance away. We compare galaxies to grains of sand on a beach. We use these analogies not because they capture the true enormity, but because they give our minds something to hold on to. something to anchor within the familiar. Without them, the vastness slips through our thoughts like water through cupped hands. Imagine standing on a quiet night beneath the stars. Perhaps you are somewhere far from city lights, where the Milky Way stretches in a glowing band across the sky. To your eyes, it looks like a dusting of faint white scattered across blackness. But what you are really seeing is a galaxy containing hundreds of billions of stars. The brain knows this as a fact. You may have read it in books or heard it in lectures, but emotionally, it still feels like lights on a ceiling, distant but not unfathomable. Our perception insists on flattening the incomprehensible into something manageable. This tendency to simplify is part of how we cope with the immensity of existence. If we truly felt, every moment, the full weight of cosmic scale, perhaps it would overwhelm us. Life must be lived in the immediate, and so our brains shield us, translating infinity into something that feels closer to home. A galaxy becomes a cloud of stars. The universe becomes a night sky. The true numbers, the light years, the billions, are stored in the intellect, but rarely penetrate the intuitive core of our minds. Even in our measurements, we see the imprint of human perspective. For centuries, distance was measured by how far a person could travel in a day, or how many days it took to move between two towns. Units like the mile, the kilometer, the league all grew from human motion and human scale. When astronomers began to measure the heavens, they had to leave those measures behind. The distances grew so vast that our familiar units broke down. We had to invent new scales, astronomical units, parsecs, light years. Each of these steps represented a kind of surrender, an acknowledgement that the human yardstick was no longer sufficient. And yet, even with these new measures, we continue to filter them through our own perspective. When we say that light takes 8 minutes to travel from the sun to Earth, we are not only describing a fact of physics, we are translating cosmic scale into the rhythm of human life. 8 minutes is the time it takes to boil water for tea. 8 minutes is a short walk around the block. We make the incomprehensible just a little more graspable by binding it to our familiar experiences. This interplay between what we can understand and what lies beyond our comprehension is at the heart of our relationship with the universe. On one hand, we crave certainty, boundaries, numbers we can write down. On the other hand, the scale of the cosmos stretches those boundaries until they vanish into the unknown. We live in a space between comprehension and mystery, between the comfort of human perspective and the of cosmic immensity. When we attempt to measure the size of the universe, we quickly run into the limits of ordinary language and everyday units. Miles and kilometers, the measures that help us navigate the Earth, suddenly feel like toys, tools too small for the job. These units are practical when describing the distance between cities, or even the span across a continent. But once we lift our gaze skyward and extend it into the cosmic ocean, we realize that the ordinary tools of measurement crumble. The universe does not fit neatly into our mile markers or road signs. It stretches so far and expands so relentlessly that the numbers themselves begin to lose meaning. To understand why, consider the distance from the Earth to the Moon. This is about 240,000 miles, or just under 400,000 kilometers. For us, that is already immense. It is a distance that would take months to cross if you could drive there in a car. But in astronomical terms, it is a small step. The Moon is our nearest neighbor, the closest celestial body, and already the scale dwarfs the distances we are used to. It reminds us of how quickly our familiar units falter. Now imagine stretching a bit farther, from Earth to the Sun. That distance is about 93 million miles, or 150 million kilometers. Astronomers gave this span a new name, the astronomical unit, or AU. It became a new yardstick, one better suited for the solar system. Saying 93 million miles feels heavy with digits, a string of numbers that is difficult to hold in the mind. But saying 1 astronomical unit simplifies the idea, giving us a neat package we can work with. Still, even the astronomical unit does not carry us very far. If we look to Neptune, the farthest major planet, it sits about 30 AU away from the Sun. That number gives us perspective. but it also pushes the boundaries of what the AU can manage. Beyond Neptune lies a vast region filled with icy bodies and comets, and farther still, the boundary where the sun's influence finally begins to fade into the greater galaxy. To speak of these scales in astronomical units feels clumsy. The numbers grow too large. Once again, we need a bigger measure. This is where light itself becomes our guide. Light, moving at about 186,000 miles per second, is the fastest traveler we know. Its speed is a universal constant, woven into the fabric of space and time. By using light as a measuring stick, astronomers created a new way to describe the cosmos. They speak of light seconds, light minutes, and light years, the distances that light can travel in those spans of time. This shift is profound. It does not simply give us new numbers. It changes the way we think about space. Distances become linked with time, and every measurement becomes a story about the journey of light. The distance from Earth to the Moon, for example, is about 1¼ light seconds. That means when you look at the Moon, you see it as it was just over a second ago. The distance to the Sun, as mentioned earlier, is 8 light minutes. To gaze at the Sun, even safely through filtered instruments, is to look back in time by 8 minutes. When we extend this idea farther, the scale begins to astonish. The nearest star beyond our Sun, Proxima Centauri, is about 4.2 light years away. That means the light reaching us tonight left that star over 4 years ago. In other words, every star you see in the night sky is already part of the past. The farther away it is, the deeper into history you are looking. Light becomes not just a measure of distance, but a bridge between space and time. To travel even our nearest star would require technology far beyond what we currently possess. With rockets of today, it would take tens of thousands of years. The sheer number overwhelms the mind. And yet, by using light years, astronomers can make sense of it, can place stars and galaxies into maps, can chart the immensity of the heavens with precision. But there is a subtle truth hidden here. Even though the units help, they do not make the distances more intuitive. Saying that the Milky Way galaxy is 100,000 light years across is precise. But what does it mean to feel that number? 100,000 years is longer than all of human history as we know it. It is longer than the rise and fall of civilizations, longer than the span of recorded language, longer even than the existence of our species in its current form. A single ray of light, moving faster than anything we can imagine, would take 100,000 years just to cross our home galaxy. Numbers like this do not sit comfortably in the human brain. They stretch our imagination until it thins like glass. This is why metaphors and analogies become so important. Imagine shrinking the sun down to the size of a coin and placing it on a map of the United States. If you did this, the Earth would be a tiny grain of sand orbiting a few inches away. Proxima Centauri, the nearest star, would be another coin, sitting more than 2,000 miles away. Already, the scale feels impossible. And yet, that is just the very beginning of the cosmic neighborhood. Scientists often use such visualizations to help people grasp what is otherwise unreachable. They invite us to picture the universe in terms of familiar objects, marbles, grains of sand, distances across a room. But even these models eventually break down, because the numbers keep rising, and the universe refuses to be contained in metaphors. There is also a strange poetry in using light as our ruler. Because light is not only a measure of distance, but also of knowledge. Everything we know about the universe comes to us through light. From the glow of nearby planets to the faint whisper of galaxies billions of light years away, it is always light that carries the information. It travels across unfathomable gulfs of space to reach our instruments, our telescopes, our eyes. It tells us the story of stars being born, of galaxies colliding, of the universe itself expanding. Light is both messenger and metric, a way of measuring and a way of knowing. As we push deeper into the cosmos, the numbers continue to grow. Galaxies that are millions of light years away, clusters that are hundreds of millions, and finally, the observable universe itself, stretching to about 46 billion light years in radius. The term observable matters here, because beyond that, The light has not yet had time to reach us. The universe may continue much farther, perhaps infinitely, but all we can measure is the light that has already arrived. Once again, we are bound by measurement, by the travel of photons across time. In this way, measuring the vastness of the universe is not just a technical challenge, it is also a philosophical one. We measure not because we expect to hold these numbers comfortably in our minds, but because each step, each unit, each conversion gives us a slightly clearer picture of where we stand in the cosmic sea. We may never fully feel what it means for a galaxy to be millions of light years away, but by naming it, by charting it, we place ourselves in relation to it. And in doing so, we begin to weave a thread of understanding that stretches from our tiny human perspective toward the infinite expanse beyond. When we think about the universe, it can feel overwhelming to leap straight into galaxies and cosmic horizons. Sometimes, the best way to understand immensity is to begin close to home, with the familiar, and then slowly step outward. Our solar system is that first step. A small island of light and motion adrift in the dark sea of space. It is our neighborhood, the one place in the vast cosmos where we know every detail intimately, because it is the place where our story began. At the center of this neighborhood burns the sun, a sphere of plasma so massive that it accounts for more than 99% of the mass of the entire system. From Earth, the sun seems ordinary, almost unchanging, rising and setting in its daily rhythm. Yet, in truth, it is a star, one among hundreds of billions in the Milky Way. It shines because of nuclear fusion, where hydrogen atoms are pressed together under unimaginable heat and pressure to form helium, releasing immense energy in the process. That energy radiates outward, and a tiny fraction of it bathes our planet, giving us warmth, light, and life. The scale of the sun itself is already humbling. If it were hollow, more than 1 million Earths could fit inside. Its diameter stretches 864,000 miles, or about 1.4 million kilometers. Light, moving at its astonishing speed, still takes more than 8 minutes to cross the gulf from the sun to our planet. This is our first anchor point in the neighborhood, the great furnace at the center, holding the planets in its gravitational embrace. Orbiting around the sun are the planets, each following its own path, each with its own character. Closest lies Mercury, a small, rocky world scorched by proximity. Then Venus, shrouded in thick clouds that trap heat so effectively its surface simmers hotter than an oven. Next comes our own Earth, blue with oceans, green with life, wrapped in an atmosphere that shields and nurtures. Beyond us lies Mars, red and silent, a world that whispers to us of the possibility of ancient rivers and the tantalizing question of whether life might once have stirred there. These 4 worlds form the inner solar system, rocky planets clustered near the sun, but beyond them, a different domain, the giants. Jupiter, a swirling mass of gas and storms, larger than all the other planets combined. Saturn, with its delicate rings of ice and dust that stretch in majestic arcs. Uranus and Neptune, colder and more distant, tinted blue by the gases in their atmospheres. Each of these giants has its own retinue of moons, some of which are fascinating worlds in their own right. Europa, with its hidden ocean beneath ice. Titan, with its methane lakes. Enceladus, spraying water vapor into space from cracks in its frozen crust. The solar system is not only planets and moons, it is also home to countless smaller bodies, asteroids tumbling through the belt between Mars and Jupiter, comets tracing long, glowing tails as they fall toward the sun, icy remnants in the Kuiper belt far beyond Neptune. Together, they form a menagerie of objects, each a relic from the formation of the system billions of years ago. To imagine the solar system is to imagine not only the planets we know from textbooks, but also this vast cloud of debris, each piece silently orbiting in the gravity of the sun. The scale of this neighborhood is not something our minds easily hold. The Earth orbits the sun at 1 astronomical unit, or 93 million miles. Jupiter sits more than 5 times farther out. Neptune, on the far edge, orbits at 30 astronomical units, nearly 3 billion miles away. A spacecraft traveling at tens of thousands of miles per hour would still need more than a decade to reach it. And even then, Neptune is not the end. Beyond lies the Kuiper Belt, home to dwarf planets like Pluto, Eris, and Makemake, stretching for billions of miles more. And beyond that, there is the Oort cloud, a vast theoretical sphere of icy objects that may extend halfway to the nearest stars. The neighborhood is not as small as it first seems. What makes the solar system fascinating is that, despite its immensity, we have begun to explore it. We have walked upon the moon, sent rovers across Mars, flown spacecraft past every major planet. Probes like Voyager 1 and Voyager 2 now drift at the edge of interstellar space, carrying with them Golden Record's tiny time capsules of human culture and music, meant for any beings who might one day find them. These missions remind us that our neighborhood is not just an abstract concept, not just a diagram in a book, but a real, physical space that we are slowly coming to know. And yet, for all our progress, we have barely left the front yard. If the solar system were scaled down so that the sun was the size of a grapefruit, Earth would be a tiny pinhead orbiting a few feet away. Neptune would be a speck orbiting more than 30 yards away. The Oort cloud, if it exists as we imagine, would stretch for miles. In this model, the nearest star would be thousands of miles farther still. Our neighborhood is enormous, but in the context of the galaxy, it is barely a dot. There is also a profound beauty in thinking about the solar system as a community. Each planet, each moon, rock of ice has its place, circling in harmony with the rest. Gravity binds them all together, a silent force weaving their orbits into a great cosmic dance. To look at it this way is to see order within immensity, to see how the laws of nature create structure even in vastness. From the swirling storms of Jupiter to the tilted axis of Uranus, each feature tells a story of formation, collision, and evolution across billions of years. The solar neighborhood is not only about physical distances, but also about perspective. When we speak of the sun, the planets, and the outer reaches of icy debris, we are really sketching the boundaries of our home in the universe. Earth is not an isolated world floating in emptiness, it is part of this intricate neighborhood. Bound to the sun, part of a larger system. Just as a person is part of a family, town, nation, so too is Earth part of this solar system. To recognize this is to feel less alone, to see our world not as solitary, but as one member of a much greater community of worlds. And though this community is vast compared to the scales of our daily lives, it remains only the first step outward. The solar neighborhood is our introduction to cosmic distances, our first training ground for thinking beyond miles and minutes. It is where we begin to stretch our imagination, to step past the limits of what feels natural, and to prepare ourselves for even greater journeys into the galaxy beyond. When we move beyond the solar system, beyond the sun and its family of planets, moons, and icy wanderers, we find ourselves adrift in something larger still, the galaxy. The Milky Way is our true cosmic home, a vast spiral of stars and gas and dust that stretches across unimaginable distances. To look up at the night sky, far from city lights, is to see only a fragment of it, a faint band of milky white light arching overhead. That soft glow is not a cloud. It is the combined radiance of billions of stars, so numerous and so distant, that the human eye blurs them together into a continuous sheen. The word galaxy itself carries a quiet poetry. It comes from the ancient Greek word galaxies, meaning milky, a reference to this very band of light that early observers could not explain. They had no way of knowing that they were looking across the plane of a massive spiral system, one that holds our sun as just one star among hundreds of billions. It is humbling to realize that everything we have ever known, the Earth, the solar system, every human story exists in just one small corner of this grand structure. The Milky Way is immense. From one end to the other, it spans about 100,000 light years. If you could ride a beam of light, the fastest thing in the universe, it would still take 100 millennia to cross from one side to the other. Within this span, are perhaps 400 billion stars, along with vast clouds of interstellar gas where new stars are born, and remnants of old stars that have already died. Surrounding it all is a halo of dark matter, invisible yet dominant, shaping the galaxy's very structure. When astronomers describe the Milky Way, they often compare it to a giant disk, flat and wide, with spiral arms curling outward like the arms of a pinwheel. Our sun lies about 2/3 of the way out from the center, orbiting along with countless other stars. This orbit takes time, roughly 220 million years, for the sun to make one full circuit around the galaxy. That means in the 4.5 billion years since its birth, the sun has only orbited the Milky Way about 20 times. The scale of time matches the scale of space, and both stretch beyond human intuition. To better grasp such distances, astronomers once tried to count stars by looking through telescopes and recording what they saw. But quickly, the task became overwhelming. No telescope could capture the entire galaxy at once. Instead, scientists turned to indirect methods, measuring the motion of stars, the rotation of gas clouds, and the faint glow of radiation. Each new observation revealed more about the galaxy's enormity, until the picture of the Milky Way became clearer, a system too vast for simple counting, too intricate for a single human perspective. Even so, our own neighborhood within the galaxy feels almost quiet. The nearest star system, Alpha Centauri, lies just over 4 light-years away. That distance feels immense when we imagine traveling it, but when compared to the full width of the galaxy, it is almost nothing. A step across the street, in a city that spans continents. To place ourselves within the galaxy is to see how truly small even our solar system is, a grain of dust among billions. And yet, the galaxy is not empty space dotted with occasional stars. It is alive with structure and motion. Stars orbit the galactic center in graceful paths, while spiral arms slowly rotate, their density waves triggering bursts of new star formation. Nebulas glow in pink and violet hues, illuminated by young, hot stars within them. Supernova erupt, scattering heavy elements across interstellar space, seeding future generations of stars and planets. The galaxy is a great ecosystem, one where birth and death, creation and destruction, play out on cosmic timescales. One of the most intriguing aspects of the Milky Way is its center. Hidden from our eyes by thick clouds of dust, astronomers discovered that at the core of our galaxy lies a supermassive black hole, known as Sagittarius A. It contains about 4 million times the mass of our Sun, packed into a region no larger than our solar system. Around it, stars whip through space at astonishing speeds, drawn by its immense gravity. This black hole, silent and unseen, anchors the galaxy, holding together the swirl of stars, gas, and dark matter. As vast as it is, the Milky Way is not unique. It is but one galaxy among countless others. But standing within it, we cannot help but feel a special bond. This is our home galaxy, the place that has cradled our sun and earth for billions of years. Every element in our bodies, every atom of carbon, oxygen, and iron, was forged within ancient stars of the Milky Way, then scattered across space before coalescing into new systems. To know the galaxy is to know our own origin, written in the language of stars. The distances within the Milky Way are so vast that they challenge not only our imagination, but also our instruments. When astronomers measure the distance to stars, they use techniques like parallax, watching how a star appears to shift as Earth moves around the Sun. For nearby stars, this method works, but beyond a certain point, the shifts are too tiny to see. Other methods rely on brightness, color, and the patterns of light, each carefully calibrated to extend our reach farther into the galaxy. Piece by piece, measurement by measurement, we build a map of the Milky Way, though it remains incomplete. Like a sketch of a city glimpsed through fog, there is something deeply comforting about the idea that our galaxy, despite its enormity, is a structure, a place with form and rhythm. We may never walk its streets or cross its spirals, but we can imagine them, we can chart them, and we can take solace in knowing we are part of something coherent. It is a reminder that even in the vastness, there is order, and within order, there is beauty, and yet, as immense as the Milky Way is, as filled with stars and stories as it may be, it does not stand alone. Beyond its edges, across gulfs of intergalactic space, other galaxies wait. They are not close, and they are not few. They stretch outward, clusters and superclusters, each one a universe of its own. Each one reminding us that the scale of the galaxy is only a stepping stone toward the greater immensity beyond. If the Milky Way feels impossibly large, stretching 100,000 light-years across and holding hundreds of billions of stars, then stepping beyond it requires a deeper breath. For as vast as our galaxy is, it is only one among a sea of others, scattered across the universe like glowing islands in an endless dark ocean. To look past the Milky Way is to expand our vision into realms even more immense, to recognize that our home galaxy is not the entirety of the cosmos, but merely a member of a vast and growing family. The first hint of this truth came from simple observation. For centuries, when people gazed at the night sky through early telescopes, they noticed faint smudges of light. Some of these were star clusters within our galaxy, but others looked different, more diffuse, more distant. Their light blurred into hazy patches. They were called nebulae, a word that simply meant cloud. It was not until the early 20th century that astronomers finally realized these mysterious smudges were not clouds within the Milky Way at all. They were galaxies of their own, vast systems of stars and gas and dust, lying far, far beyond our own. This discovery, led by Edwin Hubble and others, fundamentally changed our understanding of the universe. Suddenly, the Milky Way was not the whole story, but just one chapter. The smudges resolved into spirals, ellipticals, irregular forms, each containing billions or even trillions of stars. The universe opened outward, and humanity found itself in a cosmos populated by countless galaxies. The closest of these galaxies is Andromeda, lying about 2.5 million light-years away. To the human eye on a clear night, far from city lights, it appears as a faint, elongated blur in the constellation of the same name. But that blur is an entire galaxy, larger than the Milky Way, home to perhaps 1 trillion stars. The light we see from it tonight began its journey long before humans existed, traveling across intergalactic space for millions of years before reaching our eyes. It is a reminder that looking beyond the Milky Way is not simply about distance, but also about time. Andromeda is not alone. The Milky Way, Andromeda, and dozens of smaller galaxies belong to a community called the Local Group. Most of the smaller members are dwarf galaxies, faint collections of stars that orbit the larger ones. They are like satellites, companions bound by gravity. The Local Group stretches across about 10 million light-years, a bubble of galaxies held together by mutual attraction. It is within this small cluster that our own galaxy resides, moving silently along trajectories that will, in billions of years, bring the Milky Way and Andromeda together in a cosmic merger. When that happens, their stars will swirl and scatter, creating a new galaxy altogether. But the Local Group is still just the beginning. Step beyond it, and you enter the Virgo supercluster, sprawling collection of thousands of galaxies stretching across 100 million light-years. These galaxies are arranged not randomly, but in filaments and clusters, bound together by gravity, shaped by dark matter, and separated by vast voids. To imagine this structure is to imagine a cosmic web, strands of light crossing darkness, each node a cluster of galaxies. The Milky Way is just one thread in this immense tapestry. What makes these scales so difficult to comprehend is not only the distances, but the spaces between. Within the galaxy, stars are separated by light years, but between galaxies, the separations stretch into millions of light years. Imagine standing on the shore of an island, looking across a dark sea toward another island faintly glowing on the horizon. That is what it means to look at galaxies beyond our own luminous islands across oceans of emptiness. And yet, for all the emptiness, these galaxies are abundant. Modern surveys of the sky suggest that in the observable universe, there may be 2 trillion galaxies. 2 trillion, each one with its own stars, its own planets, its own clouds of gas, its own stories of birth and death. The number itself presses against the boundaries of comprehension. Even if you could count one galaxy every second, it would take tens of thousands of years to finish the list. Beyond the Milky Way lies not just more space, but a near infinite abundance of worlds. Some of these galaxies are massive giants, elliptical in shape, containing trillions of stars. Others are small, dim dwarfs with only a few million. Some spin in elegant spirals, their arms glowing with newborn stars. Others are twisted and irregular, scarred by collisions and gravitational tides. Galaxies are not static. They collide, they merge, they cannibalize their neighbors. These encounters play out over billions of years, shaping their structures, igniting bursts of star formation, creating ripples of energy across intergalactic space. The universe beyond the Milky Way is not quiet, it is dynamic, restless, alive with motion on the grandest scales. One of the most striking features of this greater cosmos is how small the Milky Way appears within it. Though our galaxy is large by human standards, it is only average when compared with the giants. There are galaxies 100 times more massive, with far more stars and larger halos of dark matter. Just as Earth is not the center of the solar system, and the solar system is not the center of the galaxy, so too the Milky Way is not central in the cosmic order. It is simply one among billions, a reminder of our ordinary place in an extraordinary universe. As our instruments improve, we continue to peer farther into this vastness. Telescopes like Hubble and the James Webb Space Telescope capture light that has traveled for billions of years, revealing galaxies at the very edge of the observable universe. These ancient systems appear as faint red smudges, stretched by the expansion of space. They are among the first galaxies to have formed, glowing faintly in the early universe. To see them is to look back almost to the beginning of time itself, to glimpse the infancy of the cosmos beyond our home. And with every new discovery, the picture becomes more staggering. Not only are there galaxies beyond the Milky Way, but they are organized into structures larger still, superclusters, filaments, and walls that stretch across hundreds of millions of light years. Between them are voids, enormous expanses of near-empty space, darker and lonelier than anything we can imagine. Beyond the Milky Way lies a universe that is not only vast, but patterned, shaped into a cosmic web of breathtaking scale. It is tempting to ask what it means to be part of such immensity, to realize that our galaxy, vast as it seems, is only a single thread in this web, is to feel a kind of vertigo. Yet there is also comfort in the idea. Just as our solar system feels like a neighborhood within the galaxy, so too the Milky Way feels like a neighborhood within the larger universe. We are not alone, not isolated, but part of a community of galaxies bound together by gravity and expansion. Our home may be small, but it is connected, woven into the greater fabric of the cosmos that stretches endlessly in every direction. When we lift our eyes beyond the Milky Way and its neighbors, beyond the galaxy clusters and superclusters, we encounter one of the deepest questions in all of science. How far does the universe extend, and how much of it can we truly see? The answer lies in the concept of the observable universe, a boundary not of matter itself, but of time and light, shaped by the very speed at which information travels. The observable universe is not defined by the limits of our telescopes, nor by how far we might someday travel. Instead, it is defined by light itself. Light is the messenger of the cosmos. Every star we see, every galaxy captured in the faintest telescope image, sends its story across the fabric of space, and we receive it as photons arriving after journeys of unimaginable length. But light does not travel infinitely fast. It moves at a finite speed, 186,000 miles per second, and so there is a horizon to what it can reveal. This horizon is set by the age of the universe. If the cosmos began 13.8 billion years ago, then the farthest light we can possibly see is limited to 13.8 billion years of travel. In that sense, the observable universe is like a sphere centered on us, with its edge marked by the most ancient light that has had time to reach Earth since the beginning of time itself. This is not a sphere of physical walls or barriers, but a vision, an invisible bubble defined by the speed of light and the age of everything around us. At first glance, one might think this sphere should be 13.8 billion light-years in radius, but the reality is more subtle. Because the universe has been expanding since its beginning, the galaxies that emitted the earliest light have moved farther away during the time that light was traveling. When we factor in this expansion, the radius of the observable universe is much larger, about 46 billion light-years in every direction. That means the observable universe is a sphere roughly 92 billion light-years across, containing everything we can possibly see or measure with light. What lies within this immense sphere is almost beyond imagination. Astronomers estimate that the observable universe contains around 2 trillion galaxies, each with billions or trillions of stars. It holds uncountable planets, countless clouds of gas and dust, and structures so vast they defy our ordinary sense of scale. And yet, everything we know, everything we have ever measured, is confined within this bubble of light. Beyond it, there may be more, perhaps infinitely more, but it is forever beyond our view. The concept of the observable universe reminds us that when we look into the night sky, we are not looking at space as it is, but as it was. The Andromeda Galaxy, 2.5 million light-years away, appears not as it exists now, but as it looked 2.5 million years ago, when our distant ancestors first learned to shape tools from stone. A galaxy 10 billion light-years away appears as it looked when the universe itself was young, filled with hot, bright stars just forming for the first time. The farther we look, the further back in time we go, until we reach a wall, the cosmic microwave background, the faint afterglow of the Big Bang itself. This afterglow is the oldest light we can see, a whisper from when the universe was only 380,000 years old. Before that time, the cosmos was too hot and dense for light to travel freely. Space was filled with a glowing plasma, opaque like a fog, and photons were constantly scattered. But as the universe cooled, atoms formed, and light broke free, streaming outward across billions of years. Today, we detect that ancient light as a faint microwave signal, uniform across the sky, carrying with it a map of the early cosmos. It is not just the edge of what we can observe, it is the earliest snapshot of the universe itself. To imagine the observable universe is to imagine layers upon layers of time, each one farther back than the last. Nearby stars show us the recent past decades, centuries, or thousands of years ago. Distant galaxies reveal scenes from billions of years in the past, when the first clusters were forming. The cosmic microwave background reveals the dawn of transparency itself, when light was first able to flow across the cosmos. It is as though the universe is a vast archive, with each distance preserving a deeper chapter of history. Our telescopes are not just instruments of sight, they are time machines, letting us witness eras long gone. And yet, for all its grandeur, the observable universe is not the whole of existence. It is simply the part we can access. Beyond that horizon, space may continue without end. There may be galaxies we will never see, stars whose light will never reach us, entire regions of the universe cut off by distance and expansion. The observable universe is like standing on the shore of a vast ocean. We see only to the horizon, but the ocean continues far beyond. This raises a profound question. If the universe is larger than what we can observe, perhaps infinitely larger, then what does it mean to comprehend its size? Our measurements, precise as they are, describe only one bubble within a potentially endless expanse. We can count the galaxies within our horizon, but we cannot know how many lie beyond. We can trace the filaments of the cosmic web within our view, but the pattern may extend far past our sight. The observable universe gives us boundaries, but those boundaries may only exist for us, not for the cosmos itself. In this sense, the observable universe is as much a reflection of our limitations as it is of the cosmos. It reminds us that what we call the universe is always shaped by where we stand, by the tools we use, and by the speed of light itself. If we had been born earlier in cosmic history, the observable universe would have been smaller. If we were born far into the future, it would appear different again, as galaxies slip beyond our horizon, carried away by the accelerating expansion of space. Our observable universe is unique to this moment, a snapshot shaped by time and place, and yet, even within those boundaries, the scale is overwhelming. 92 billion light-years across, 2 trillion galaxies, stars, and planets beyond numbering. To hold such immensity in the mind is nearly impossible. Our brains resist, just as they resisted when we tried to imagine the size of the solar system or the span of the Milky Way. But there is a quiet beauty in that resistance. It means we are brushing against the limits of comprehension, standing on the edge of the infinite, aware enough to know there is more than we can ever fully grasp. The observable universe, then, is both a scientific concept and a meditative one. It tells us the limits of our vision, but it also invites us to contemplate what lies beyond. It grounds us in numbers and measurements, yet it lifts us into wonder and humility. It is not only about what we can see, but about the mystery that forever recedes from sight, pulling us deeper into reflection. To think of the observable universe is to feel small, yes, but also to feel connected to something vast, something ongoing, something that stretches endlessly into horizons we may never reach. There comes a point in exploring the universe where numbers themselves begin to lose their meaning. At first, when we speak of miles or kilometers, the mind can still imagine. We can picture a drive across the country, or a flight across the ocean, and feel the distance in our own experience. Even thousands of miles remain tangible, because they link to something we can live, something we can sense. But as soon as we step into the scales of astronomy, the ordinary anchors of human life begin to fall away. Consider the light year. It is defined as the distance light travels in 1 year, moving at 186,000 miles per second. In 1 second, light can circle Earth more than 7 times. In 1 year, it travels nearly 6 trillion miles. The number itself is almost too large to say, but astronomers use it casually, as if 6 trillion miles were just another measure like a dozen steps or 100 yards. 6 trillion miles is the shortest stride we can take in cosmic measurement. And even this, even the light year, begins to feel inadequate almost immediately. Our nearest neighboring star system, Alpha Centauri, is over 4 light-years away. That is 25 trillion miles, a number so large that if you tried to count each mile aloud, 1 per second, you would need nearly 1,000,000 years to finish. Even imagining this distance requires tricks of metaphor. If the sun were the size of a grain of sand, Alpha Centauri would still be over 4 miles away. Already, the mind resists, and yet, we are still close cosmically speaking. These are neighbors just across the street. The Milky Way itself is 100,000 light-years across. That means a beam of light, moving faster than anything else in the universe, would still take 100,000 years to cross it from end to end. Try to imagine that in years of human history, 100,000 years ago, humans had not yet built cities, not even cultivated crops. Our ancestors roamed the earth in small groups, living by firelight and stone tools, while across the galaxy, light was only beginning a journey that is still not ended. The scale bends time as easily as it bends distance, reminding us that both are woven together in the cosmos, and beyond the Milky Way, the numbers continue to climb. The local group of galaxies, our small neighborhood, spans 10 million light-years. The Virgo cluster, a nearby congregation of thousands of galaxies, stretches over 50 million light-years. The Laniakea supercluster, the vast basin of gravity, in which our galaxy resides, spans 500 million light-years. Each increase in scale demands a new metaphor, a new way of framing the unimaginable. And still, these numbers are mere steps within the observable universe. When we reach billions of light-years, our language falters. To say the observable universe is 92 billion light-years across may be accurate, but accuracy alone does not create understanding. 92 billion light-years is a number so large that the human brain has no evolutionary preparation to handle it. Our minds evolved to measure distances by steps and landscapes, not galaxies and cosmic horizons. The number becomes like a fog present, real, but impossible to grasp in full. This is why astronomers often use metaphors, comparisons that shrink the cosmos into something we can hold, even if only for a moment. If the entire observable universe were scaled down to the size of Earth, the Milky Way would be no larger than a single grain of sand. If every star in the universe were reduced to a single drop of water, the observable universe would be an ocean, larger than all the seas on Earth combined, an ocean so vast it would dwarf imagination itself. These metaphors are not precise, but they help bridge the gap between what we can measure and what we can feel. Yet, even metaphors can only go so far. At a certain point, the numbers remain like cliffs, sheer and insurmountable, standing before us as reminders of our limits. 2 trillion galaxies in the observable universe, perhaps sextillions of stars, more planets than grains of sand on every beach on Earth. These numbers are so far removed from our daily lives that they break the mind's ability to relate. We may nod when we hear them, we may feel awe, but we cannot truly picture them. They stretch beyond comprehension, and in doing so, they transform into something else. Not facts we can hold, but mysteries we can only sit with. There is a quiet peace in this breaking point. When numbers become too large to comprehend, they free us from the need to comprehend them. We do not have to hold every star in our mind, or every light year, or every galaxy. We can instead rest in the knowledge that they exist, that they are out there, vast and real, shaping a universe too wide for us to ever fully grasp. The inability to comprehend becomes its own kind of understanding and acceptance that the cosmos is larger than thought itself. And still, the numbers invite us to try. They invite us to stretch our imagination just a little further, to linger at the edge of our mental horizon, to think of a billion not as a cold statistic, but as a rhythm of time. If you counted one number every second, day and night, it would take you 31 years to reach a billion. To count a trillion would take you 31,000 years. To reach a quadrillion, 31 million years. Suddenly, the scales of galaxies and stars do not just feel large, they feel timeless, stretching across spans greater than civilization itself. What these numbers reveal is not only the size of the universe, but the smallness of our own moment. Human history, from the earliest cave paintings to the rise of modern science, spans perhaps 40,000 years. That is less than the blink of an eye compared to the billions of years written across galaxies. Civilizations rise and fall in the space of a cosmic heartbeat, and yet within that heartbeat we measure, we explore, we look upward, and ask questions. Our numbers break, but our curiosity continues. Perhaps this is what makes the numbers so powerful. They remind us of our limits, but also of our reach. Even when we cannot hold them in the mind, we can calculate them, describe them, chart them. In equations and models, our species, small as it is, has managed to look out across 92 billion light-years of space and measure it with precision. We cannot comprehend the number, but we can discover it, and that discovery itself becomes part of our story. As you let your mind drift on these numbers, it is natural to feel small, even overwhelmed. But there is also comfort here, for the same numbers that stretch beyond our comprehension also connect us to the vastness around us. Every number is not just a statistic, but a reminder that we belong to a universe immeasurable, unfolding in ways we can only glimpse. Our minds break on the scale, but they open in wonder, and in that opening, we find perspective, humility, and peace. When we ask whether we can comprehend the size of the universe, the question itself hides a paradox. On one level, comprehension suggests something clear, a grasp, a way of fully holding a truth in the mind. On another level, comprehension acknowledges our limits, because the very scale of the universe challenges what human thought was designed to do. We evolved to notice the nearby, to survive in forests, grasslands, rivers, and mountains. Our brains were tuned to perceive a world measured in steps, in days, in seasons, in lifetimes. The stars above were lights in the night sky, mysterious but distant, never demanding to be measured. And yet here we are, attempting to comprehend the immeasurable. True comprehension of the universe's size may not lie in numbers alone, or in the metaphors we stretch across them. Instead, it may rest in our ability to accept both what we can know and what we cannot. To know that the observable universe stretches 92 billion light-years across is a fact, but to say we understand it requires something different. A surrender to the vastness, a willingness to hold the idea without expecting it to shrink into the neat boundaries of our imagination. There is something soothing in this surrender. Comprehension here is not about control. It is not about reducing the universe into something small enough for the mind to manage. It is about expanding our sense of awe, and letting awe itself become a form of understanding. Perhaps comprehension does not always mean to grasp tightly. Perhaps it sometimes means to rest gently, like floating on the surface of a vast ocean, unable to see its bottom, but aware that it surrounds us, supports us, and holds mysteries too deep for us to ever measure. When astronomers chart the stars, galaxies, and clusters that make up the universe, they are not claiming to hold it all in their minds. They are creating maps, tools, models, ways of pointing toward the incomprehensible. The numbers, the images from telescopes, the equations of physics, are like lanterns in the dark. Each illuminates a small space, a patch of the vast expanse. To comprehend the universe, then, may mean learning to live with lantern light. To know that our vision is partial, and yet to be at peace with that partial vision. There is a unique comfort in this. For in daily life, we often struggle with the unknown, the uncertain, the ungraspable. We want answers, clarity, control. But the universe, in its size, teaches us something gentler. It shows us that not everything can be measured in ways that feel complete. It shows us that incompleteness is not failure, but an invitation to wonder, to marvel, to stretch the imagination toward horizons it will never fully reach. Think of the night sky, filled with stars. You cannot count them all, even if you try. But standing beneath them, you feel their presence. You sense their depth. You comprehend not through calculation, but through experience. The comprehension comes not from the number of stars you can name, but from the feeling they stir inside you. A sense of infinity, quiet recognition of your place in something much larger. This too is comprehension, though it does not use numbers. It uses awe as its language. When we shift our view this way, the impossibility of fully grasping the universe's size becomes less of a problem and more of a gift. It frees us from the burden of trying to make the infinite small. Instead, it allows us to grow into the mystery. To comprehend, then, is not to enclose, but to open. Not to shrink the universe to our scale, but to let our sense of scale expand into something more spacious than our minds alone. Consider how children learn about the world. They do not begin with precise definitions. They begin with impressions, sensations, feelings of wonder. A child looks at the ocean and sees not its depth measured in feet, but its endlessness. A child looks at the night sky and sees not its light years, but its sparkle. And that impression, though imprecise, is true in its own way. We might say that comprehension begins here in openness, in awe, in a willingness to encounter without fully containing. So perhaps when we ask whether we can comprehend the size of the universe, the better question is, what kind of comprehension are we seeking? If it is the kind that demands a perfect mental picture, then no, we cannot. But if it is the kind that allows us to rest in the presence of something vast, then yes, we can. We comprehend not by enclosing the cosmos in the limits of our mind, but by recognizing our mind's place within the cosmos. This shift has a calming quality. It reminds us that we are not required to solve everything, to hold everything, to calculate everything down to its smallest detail. The universe is larger than calculation, and that largeness is not threatening. It is simply what is. To comprehend this is to let go, to allow the mystery to remain, and to find peace in being a small part of it. In this way, comprehension becomes more like listening than speaking, more like receiving than controlling. We do not demand the universe reveal itself entirely. We let it whisper to us in fragments, in glimpses, in small pieces of truth scattered across an ocean of stars. And in listening, we grow, we expand, not by conquering the scale, but by dwelling within it, quietly, patiently, like a traveler resting beneath an endless sky. The great paradox is that this kind of comprehension feels both vast and intimate. It acknowledges a universe beyond measure, yet it also draws us closer to ourselves. For in recognizing the scale, we see our place in it, not rulers, not masters, but participants in a story that began long before us and will continue long after. To comprehend is to feel the connection, the belonging, the way we are stitched into the fabric of something unthinkably immense. And so, as you drift through these thoughts, let your mind release the pressure of solving the infinite. Let it soften into a different kind of knowing, the kind that does not hold tightly but opens gently, the kind that finds peace not in the answer, but in the wonder itself. The size of the universe may be beyond what numbers can place neatly in the mind, but it is not beyond what the heart can rest in. It is not beyond what imagination can stretch toward. It is not beyond what awe can hold softly, like a dream unfolding in the quiet of the night. As we have wandered together through these reflections, we have traveled from the scale of our everyday lives to the unimaginable reaches of the cosmos. We began with the simple truth that our minds were shaped for human-sized experiences, steps, distances, lifetimes, and yet, we dared to stretch them outward. We explored the language of light years, the way we measure what cannot be measured, in miles or days. We lingered within our solar neighborhood, realizing how even the space between our sun and its nearest companion star is already beyond the scale of our imaginations. We drifted across the Milky Way, a galaxy so wide and full of stars that it resists every attempt to make it small. We ventured past it, to galaxies upon galaxies, separated by oceans of space, reaching all the way to the edge of the observable universe, where light itself has traveled for billions of years to greet us. And yet, through all of this, we discovered something more than numbers or distances. We discovered the strange and beautiful truth that comprehension is not always about control, and not always about grasping the whole. To comprehend the universe may mean to rest within its mystery, to allow its vastness to soften us, to remind us that there is beauty in what cannot be held. Numbers may fail us, but awe never does. Equations may stretch beyond our reach, but the feeling of looking up at the night sky belongs to everyone. In this way, the universe offers us a gift. It humbles us, reminding us that we are small, but it also lifts us, reminding us that we are part of something boundless, stitched into a fabric that extends farther than our minds can imagine. To comprehend the size of the universe is not to shrink it into something manageable, but to expand our sense of wonder so that we may live alongside it. So, as you rest now, let yourself be carried by this thought. You do not need to hold the whole universe in your mind to belong to it. You already do. Every breath, every heartbeat, every glance at the stars is a quiet connection to the infinite. And in that connection, that gentle awareness, lies a deeper kind of comprehension, one that soothes, one that humbles, and one that will always guide us back to wonder.